All right, sixth grade, welcome to electronic math. All right, make sure you got your notes handy, and you can certainly stop and pause this to absorb what's going on. We got 3 lessons today and in this week that you're going to be responsible for, and they all really apply to the same thing. It's your ability to write and use proportions. And so the first is lesson 71, where you use a proportion, or you could use the book's way if you wanted to find the whole when they only tell you a fraction of it. There are 2 ways to do this. You have the book's way, which we have used in the past, where you make a diagram and you use the fraction denominator to chop up the picture into equal parts. And then you figure out how many are in each equal part, and you can use that to get the answer, and that's fine. All right. However, I think you're going to find that for this lesson and the next other lessons, that a better way to look at this is to identify this as a proportion, where you have a fraction that is equal to a part over a whole. And the fraction, we've talked about sign of the cross as a given amount. A fraction has a numerator and a denominator, and that is equal to the part over the whole. And so you have this whole relationship of using a proportion to solve for the missing numbers. But it's up to you. You can do it either way. You'll see things like, all right, and this is slightly different than what we've done before, so you got to pay attention to how it's worded. 3/5 of the fish are bluegills. Bluegills are fun to catch. If there are 45 bluegills, how many fish are in the pond? All right, so 45 bluegills is not the whole number of fish in the pond. That's only 3/5 of them. That means 2/5 of the pond are different kinds of fish, right? 3/5, what's left is 2/5. That might come in handy, who knows? So if we want to use the book's method, we use this denominator 5 here in the fraction to divide up the pond into 5 equal parts. And 3 of those parts, 1, 2, 3 of them, represent the bluegills. All right, 3 of them. 1, 2, 3. So if 3 of these parts represent bluegills, and there's 45 of them, that means each part is 45. Chopped into 3 equal parts, 45 divided by 3. Each part has to be 15 bluegills, or 15 fish, right? And 3 of those parts make 15 plus 15 plus 15, that's 45, all right? The question says how many fish are in the pond? Well, if all 5 parts are 15 each, and there's 5 parts, then 15 times 5 gives you the total number of fish in the pond, 75. All right, so that works. On the other hand, you could take a look at it using a proportion that says the fraction that we're interested in, 3/5, is equal to the part that we know, in this case 45, over the whole thing. We don't know, n. And then it becomes a matter of 5 times 45 divided by 3, and guess what? You get 75 fish in the pond. 2 different ways of doing it, all right? Take a look at this. At page 51, he was 3/8 of the way through the book. All right, so on these problems, after the first sentence, stop and think about it. Visualize what's going on. All right? He's on page 51, but he's not through the whole book. He's not even halfway through the book, right? 3/8 isn't even halfway. The question is, how many pages are in the whole book? Well, if we use this method, we would say the fraction that it gives us, 3/8, is going to be equal to the part. In this case, the part is 51 pages, not the whole thing. And we want to find the whole thing, so we use the letter n for the number that's missing. And so to find the whole number of pages in the book, we do 8 times 51 divided by 3, 408 divided by 3, 136 pages. Which makes sense, because if he was halfway through the book at 51, there'd be 102 pages in the book. But he isn't, so there should be more than 102 pages in the book, and so that makes our answer reasonable. Here's another example. 3/5 were turned on and 30 lights were off. I mean, if you just jump into that problem like this right now, it's very confusing. So stop, step back, and think about what's going on. 3/5 were on, all right? More than half the lights are on. And that more than half number represents 30 lights, all right? Maybe it's a Christmas tree, who knows? The question says, how many lights were on? Well, if 3/5 were on, that means what's left, 2/5 were off. We could use a diagram here and say, once again, we've got 5 equal parts. So we've got the whole number of lights chopped into 5 equal parts, and 3 out of those 5 are on, all right? And 2 out of those 5 were off. But we only know the number that were off. So this number 30 here represents 2 parts that are equal. So using this method, we could figure out that there were 15 in each part, which means I've got 5 parts of 15, all right? Which means there's 75 lights altogether, but that's not what the question's asking. If 15 and 15 were off, 15, 15, and 15, 3 out of 5, are on, that would be 45 lights that are on, and that answers the question. The other way to do that then would be to say if 3/5 are on, that means 2/5 are off. And that 2/5 goes with the part that we know about, the 30 lights. So therefore I can use my proportion using 2/5 equals 30, the part, over the whole thing we're trying to find. And that, again, 5 times 30 divided by 2 gives me 75 total. Well, if I know 75 is total and 30 are on, what's left, 75 minus 30, gives me the answer of how many are on, 45. Different ways to do this, all right? But again, you have to be careful in your reading, all right? Make sure you just read the first sentence, step back, think about it, and get an idea of what's going on, and you won't mess it up. And that's it. That's as hard as it gets. So your first task in math this week is to do lesson 71, A to D, and 6 to 10. Thanks.